So you're looking at this and saying, hey, what's this old? What do test questions look like? That's an old test question. All right, let's ask the question. Is it possible to find the external support reactions? What are the external support reactions? Is it possible to find the external support reactions? Okay, first of all, let's do this. If this is 300, what are these? What are these?
75.
So technically, I don't need that pulley system anymore. All I need is to know that coming into this pin at B, there's 150, coming in here 75, coming in here 75. You can basically get rid of the pulley system. Now, having gotten rid of the pulley system, can I find the external support reactions? What are the external support reactions? A cable, which is over there at A, and a CX and a CY. Can I find it? Yeah, there's 3 unknowns, CX, CY, and T. Right? So I could draw a free body diagram, the whole damn thing, and solve for the cable and the CX, CY. Yes?
Yes.
Okay, I'm not going to do that. I'm going to skip step 1. It is not mandatory to do step 1. I'm saying to you, it's probably in your best interest to do step 1. Do I have to do step 1? The answer is no. I didn't have to do step 1 in the previous problem, and if I hadn't, then I'd have to draw another free body diagram, which is that of the slanted member ABC, and write 3 more equations to get things in that diagram. But because I drew the free body diagram of the whole thing, I was able to get AX, AY, and HY, which basically said I don't need that slanted member ABC in order to get the rest of the information. So is it mandatory to do a free body diagram of the whole thing and find the support reactions? No. I'm suggesting you do that to help you out. Because usually that's an easy free body diagram. In this one, I'm just going to break the rule and say, fuck it. I'm going to start dismembering this whole damn thing from the beginning. Well, there's no pin there. That's just a letter G to indicate that's that point. The pins are here, 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 and there. Now, what I don't want you to do, I don't want you to think of it as member AB, then member BC. It is one long member that I'm pinning at A, B, and C. That is not member AD and then member D, whatever. It's not member DG and then BD. No, it's one solid member that's pinned at 3 locations. Or 2 locations. Does everybody understand that? Think of your folding chair that you put into a bag. If you look real closely at the legs, it's not one piece, another piece, another piece. It's not 4 pieces. It's one solid piece down, another solid piece down, pinned in the middle. And now you know why it's pinned in the middle. Why is it pinned in the middle? So I can take those legs and basically fold them. Because the pin does not resist moment. It resists X, it resists Y, but it does not have a moment to stop it from rotating. So you're able to rotate it, squeeze it together, and then put it in the bag. Right? But if you look real closely, it's 1 piece, 2 pieces, it's not 4 pieces. These are not pieces, these are one solid members, all the way through a solid member, all the way through a solid member. Pin, 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 pin. Got it? All right, so I'm going to start by doing a free body diagram of BG. Free body diagram of BDG. That's this vertical piece that I'm going to have a pin at B, which means I have a BX, I have a BY. At D, I have a DY, I have a DX. This distributed load is single force resultant of 1/2 of the base, 6, height, 300, that's equal to 900. So I have 900 here from the distributed load. Where is it acting? It's acting 4 feet from D. How do I know? Well, the centroid sits right here, which is 1/3 of the base, which is 2, or 2/3 of the base, which is 4. So from here to here, it's 4. From here to the end, it's 2. 1/3 from the fat end, 2/3 from the skinny end. That's it. What do you think I'm going to write first? No, I'm going to include it on the horizontal. I'm going to do a moment. I'm going to do a moment right here at B. If I do a moment at B, what should I get right away? I should get dx. So there we go. Some moments about B equals 0. Clockwise positive. 900 times 8. That is clockwise. This is counterclockwise. Minus 4 times dx equals 0. Dx is 1800. I got a positive answer to the left. I'm going to do some forces in the x equals 0 right away. Positive to the right, bx minus 1800, which is dx, plus 900 equals 0, or bx is equal to 900, positive to the right. Some forces in the y equals 0, positive up. by minus dy equals 0, or by equals dy. I didn't always get an answer. You're not. How many unknowns do you have? 4. dx, by, dx, dy. How many equations? 3. Impossible to get all the values. So you ended up with a relationship. Great. No problem. Next, I'm going to draw a free body diagram of AD. That is AX, AY, DY, DX, and I have 600 going that way. I do know dx. Put it in. dx is 1800. Please note, when I drew dx, dy, they're equal and opposite to what I drew before. Newton's third law. Okay. Now what? I'm going to do some moments at A equals 0. Clockwise positive. That's going to be dx times 4, which is 1800. I already know that one. Minus 4 times dy plus 600 times 7 equals 0. the distance of this force to B, or to A, is 4 plus 3, which is 7. So dy comes out. dy is 2850, which means it is positive. Now that I have that, I go back over here and say, hey, by is 2850. Because I know what dy is, and by equals dy. Next, some forces in the y equals 0, positive upwards. Ay minus by, sorry, no. dy minus ay equals 0, or dy equals ay, which means ay is 2850. And it is downward. Some forces in the x equals 0, positive to the right, dx minus ax plus 600 equals 0. We know this is 1800, so ax is equal to 2400, and it is to the left. You're leaving me? I know, you didn't expect me to leave. Okay, have a good one. You with me?
Yeah.
Are we getting there? Are you following what I'm doing?
Yes.
That's the important part. Next, we're going to draw a free body diagram of A, B, C. Well, external support reaction T is here. I have a value AX, I have a value AY. Do I know those values? Yes, I do. AX, 2400. AY, 2850. Next, I should see a BX and a BY and 150 from the cable, 175 from the pulley, 75 from the pulley, 75 from the pulley, and then I should see a CX and a CY. Do I know values? Yeah. BY is 2850. BX is 900. How many unknowns left? 3. CX, CY, and T. If I do a sum moments at A equals 0, and I take counterclockwise positive, by doing a moment at A, I eliminate AY, AX, and T. Remember, best thing to do is try to eliminate as many variables as possible. So if I do a moment at A, notice all of these wipe out, that wipes out, CX wipes out, and I can get CY. So summing moments at A, I have a minus BY times 4, minus 150 times 4, minus 75 times 5, minus 75 times 6, plus CY times 10 equals 0. But I already know what BY is, put it in, 2850. Voila, CY comes out. CY is 1282.5. Do a sum forces in the Y equals 0, positive upwards. That's going to be CY minus 75, minus 75, minus 150, minus 2850, which is BY, plus 2850, minus T equals 0. I already know what CY is, 1282.5. T comes out, 982.5. And then, sub-forces in the x equals 0, positive to the right, CX plus AX minus a BX equals 0. We already know this is 2400, BX is 900, CX comes out, minus 1500. What's a minus sign say? Hey, you goofed on this. CX is really 1500 going that way. You guys are awfully quiet today. You're hungry. Me too. Maybe that's why I'm quiet too. It's in the back. They just don't.